Find a basis for the eigenspace corresponding to the given eigenvalue. So lambda equals 4 is an eigenvalue of this matrix A. And based on this eigenvalue, we need to find a basis for eigenspace. So that is same as saying eigenvector. Okay, and how do we find this? We know that we just solve if lambda is an eigenvalue if ax equals lambda x, and we are trying to find this x. In fact, it's a 2 by 2, so x will be a vector in R2, and we will have infinitely many values, infinitely many choices for x, in fact. And if we multiply by 0 as well, it will be a straight line. Okay, and we know that any straight line passing through the origin is a subspace, and that is an eigenspace. Okay, in fact, for eigenvector, for the basis we cannot have 0, but anything else on this line. So we set up in this way: ax equals lambda x, and try to find x. Okay, so this is just the background. So a basis, say x is, it's a 2 by 2, so it will be just say x1 x2 be a basis. Then we'll have ax equals lambda x. That is a times x. So a is 10, negative 9, 4, negative 2. So a x, just x1 x2 equals lambda 4 x. X is x1 x2. Okay, let's solve this. So we need to multiply. So we multiply this row to column, row to column. So this one. So 10x1 minus 9x2, that in the first, and here 4x1 minus 2x2. Okay, when we multiply, so we get this matrix or vector is equal to multiply by 4, that will be 4x1 4x2. Okay, now we are saying this vector equals this vector, so that means the first one should be equal to 4x1. So 10x1 minus 9x2 should be equal to 4x1, and at the same time 4x1 minus 2x2 must be 4x2. Okay, let's solve this. 10x1, subtract 4x1 from both sides. So if we subtract 4x1, so 10 minus 4, so 6x1, we can add 9x2, so that is 9x2. Here, oh, what is this? Now 4x1, oh, this is 4x2, okay. I thought that was x1. So 4x1, let's leave in the left hand side, add 2x2 to the both sides, so 4 plus 2, 6x2. Okay, this implies we can divide by 6, so x1 is in fact divide by 6, so 9 over 6, that's 3 halves x2, and we should get the same thing from here, and that's the case. X1 is 6 over 4, which is 3 halves x2. From both we get the same information, so we don't need this. So from here, now we got infinitely many choices, because whatever x2 value we choose, x1 is 3 halves of that. So that will be thus a basis for the eigenspace, because it will be a straight line if we include 0, 0, and there are infinitely many values. Okay, infinitely many points. So just we need one, and you can choose the easiest, x1, x2. Let's choose x2. Okay, x equals x1 x2. We don't have to write, but I wrote anyways. Choose x2 nice number so that we get this one. I mean, any value except 0 would work. I would choose 2. Why? Then this is 3 halves times 2, then I get just 3. Or you could have chosen 1, and that would make x1 equals 3 halves. That would work as well. Okay, 3 over 2, pretty much an eigenvector for the eigenvalue.